let's talk about chapter 15, which is on measuring angles and different ways to measure angles. So first, a long time ago, like the Babylonians or something, they were approached to this problem. They wanted to know how to measure an angle, and they dealt with circles. And they really liked the numbers like 360 and 60 because 360, and of course we know we use 360 degrees in a full circle, 360 can be divided by a whole ton of numbers. It can be divided by 2, you can break it in half, you can divide it by 3, you can divide it by 4, you can divide it by 5, by 6, not by 7 evenly, you get a decimal left over. You can divide it by 8, you can divide it by 9, by 10, not 11, divide it by 12, not by 13, but you can divide it by 15. Can't divide it by 14. If I go 360 divided by 14, it gives me 25.7. So all the way to 15ths, you can divide it into so many pieces, so it's really nice. Let's say we made 100 degrees in a circle. We can divide that by 2, not evenly by 3. You can divide it by 4, right? 25. You can divide it by 5, not by 6, not by 7, not by 8, not by 9. You can divide it by 10, not 11, not 12, not 13, not 14, not 15. So if we want to divide, if we decide we're going to have 100 degrees in a circle, you can only divide it in half, divide it in half again by fifths. Can't divide it into like, 6 pieces or 8 pieces, or it just doesn't work out very well. So 360 is a perfect number. It's a great number to use for a circle. The other numbers people used to like are 60, because again it can be divided by a whole number of things, and 12. 12 can be divided by, right, it can be divided by 2, by 3, by 4, not by 5, but by 6. So 12 is also a great number. 10, right, 10 can only be divided by 2, not 3, not 4, and 5. So you can only divide 10 evenly by in half and into fifths. Well, 12 can go into half and thirds and fourths, and divided by 6, divide it in half and get 6. So 12 is actually a better number. That's why a lot of people think that we really should have had a base 12 system instead of base 10. We should count to 12 and then start over, not to our normal 10, because 12 is a just friendlier number. You can divide it into pieces easier. But we got 10 fingers, and so the 10 people won. But so ancient people like the numbers 360, 100, 60, 12. That's why in our time system we have 60s and 12s and stuff, because they make more sense. Just because we have 10 fingers probably that we use base 10. Okay, so they decided to have 360 degrees in a circle, which makes a lot of sense. Now, let's say you don't have a perfect number of degrees. Okay, let's say that you're doing a problem and you measured it and it's 23.7 degrees. Okay, well, 0.7 is a decimal, that's base 10. But they didn't like base 10. So they used instead, they broke up 1 degree, they broke it up into 60ths, and they called those minutes. So 1 degree is the same as 60 minutes of arc, or arc minutes. So I could call those arc minutes, because they're not minutes of time, they're minutes of measuring an arc or an angle. So they broke it up into 60 arc minutes. The easier way to write that is they just put a little dash there. That means 60 arc minutes. So instead of saying, so 1 degree is 60 arc minutes, therefore 0.7 degrees, you just multiply by 60. 60 arc minutes is the same as 1 degree, right? 1 degree is 60 arc minutes. The degrees cancel, so you just go 0.7 times 60. Let's see, that's 42, that's 42. So 42 minutes. So 23.7 degrees is the same thing as 23 degrees and 42 minutes. Okay, so that's one example here. So again, they didn't like tenths, because that's what this is. They liked 60s, if not 360s, at least 60s. So a degree is, okay, so that's how you change it. 0.7 degrees is 42 minutes. Let's do another example. And this is like 13.1. 13.1 just has you converting, 15.1 has you converting things like this. Let's do a little bit harder one. Let's say we have 44 degrees, I'll put the degrees last, 44.378 degrees. Okay, well the 44 stays the same, it's 44 degrees, but we have 0.378 of a degree. So first we go 0.378 degrees times 60 minutes per 1 degree. And that's just to make sure we're doing it right. Yep, that's right. Units cancel. So what's 0.378 times 60? 0.378 times 60. I get 22.68 minutes. Okay, so that's 22 minutes with a little bit left over. Okay, so right now we have, it's 44 degrees, 22 minutes, and you never say decimal of minutes. Instead, we do the next one, which is seconds. So 1 arc minute, they decided it would be, that's the same thing, just like time, is 60 arc seconds. So it's just like time, but you throw an arc in there to know what you're talking about. And they decided to write that, again, 1 minute, instead of writing arc minutes, takes a lot of time, just put a little dash, and that's the same as 60 arc seconds. You put 2 dashes there, 2 little yeah, 2 little dashes. Okay, so 1 arc minute is 60 arc seconds. So now we have 0.68. We take the decimal from the arc minute, so just 0.68 arc from the arc seconds. Sorry, from the arc minutes here. And why did I write 2 of those? It'd be 22.68 arc minutes. We take the 0.68 because we don't want a decimal there, and we we have 0.68 arc minutes multiplied by 60 arc seconds per 1 arc minute. The dashes cancel, the minutes cancel. So what's 0.68 times 60? So 0.68 times 60, and I get 40.8 seconds. You can have decimals with seconds. I think a long time ago they just rounded off. Arc seconds are so small that they just figured out it's good enough, we'll just round off. But we're going to keep the decimals. So it's not perfect, we still use decimals, but only for the arc seconds. So finally, it'd be 44.378 degrees is 44 degrees, 22 arc minutes, and 40.8 arc seconds. And now we're done. So again, you'd multiply the decimal by 60 to get arc minutes. If you have a decimal, just get the whole number. That's how many arc minutes. Take the decimal, multiply by 60 again to get arc seconds, and then you keep a decimal if you get it. Okay, it's a lot easier to go the other way. Let's say that we went 2 degrees and, I don't know, 47 minutes and 52.8 arc seconds. How many decimal degrees is that? Let's say we don't like this system, we want to change it to a decimal. So we go, first of course it's 2 degrees, so it's 2 point something, right? And 47 minutes, 45 minutes is 3/4, so it's going to be like probably 0.7 something. But that's real easy. That's the same as 2 plus 47 over 60ths, right? Because 47 minutes is 47 over 60ths of a degree. And then plus 52.8 out of 60 times 60. Because an arc second is 1/60th of 1/60th. So it's 1/3600, so 3600 in the bottom. So then we just do this in the calculator and add those up. So that's 2 plus, and if you go 47 divided by 60, you get 0.78333 forever, plus 52.8 divided by 3600 is 0.01466666 forever. And so you end up getting, if you add those up in your calculator, so keep all these decimals if you can in your calculator and keep lots of decimal places, I end up getting like 2.798 degrees. So going this way is a little bit easier. You just take the 47, divide that by 60, divide this by 3600. Since 1 arc second is 1/60th over 60th, so it's 1/3600th of a degree. Tiny, tiny angle, right? You're never going to measure that on your protractor. Yeah, okay. So that's how you change from arc minutes to arc seconds. Now the one thing we didn't talk about was radians, and all you got to know for that is, and we'll talk about, I'll make a whole nother video on radians, is that 1 radian, or yeah, 1 radian is the same as, well, actually I should, okay, 1 radian is about 57.3 degrees, which is awkward, but instead the better way to write that is 2 pi radians is the same as 360 degrees. 1 circle is 2 pi radians because there's 2 pi radius. 2 pi times the radius is a full circle. And we'll talk more about radians in another video. So if we divide both sides by 2, this basically our conversion factor is pi radians is the same as 180 degrees. So if you have degrees and you want radians, so let's say we have 60 degrees, we want radians, we multiply by pi over 180. The degrees cancel, degree on the top, degree on the bottom, we know we did it right. And let's see, that's 1/3, so that'd be pi over 3 radians. And normally you don't need to write the radians, it's assumed it's radians, but if you forget what you're dealing with, you put a radians. But you got a pi in there, you know you're dealing with radians. If you want to go the other way around, you have, let's say, 2 radians, and you want degrees, you multiply by 180 degrees is the same as 1 radian, as pi radians. 180 degrees, same as pi radians, the radians cancel. And we get that 2 radians is, let's see, 360 divided by pi, whatever that is. You can leave it a lot of times with pi's, or you just put that in your calculator and figure that out. Okay, that's pretty much 15.1, maybe a little bit of 15.2 and 15.3, but I'll go over more of radians in the next video, which will help you a lot with certainly 15.3 and all the rest of the ones in this chapter.